Yes, sir.
Okay. So now here condition. This is very, very important. This is condition for multiplication. For multiplication. Condition for multiplication is like this. So let's say m by n matrix is there, and this is a m by n, and this you have to multiply with another matrix b. Then it must have your number of columns should be equal to number of rows of the second matrix n by p. Let's say this number of rows. You understand? Now that is the reason we saw that here. Let's say you have here 1, 2, 3, 4. You have here 4, 5. You have here number of columns, number of 2 columns are there. 2 columns like this, 2 columns. First row has 2 elements. If first row has 2 elements, that means what? Second row must have 2 elements. So 2 columns are there. So then we are multiplying with this. We are multiplying with this. That means what? 2 rows. So therefore, number of columns must be equal to number of columns must be equal to number of rows of the second matrix. Then it's possible. So then see like this 2 equal to this 2. So this n must be equal to n like this. So then what we say, this is the number of columns. Number of columns of first matrix equal to number of rows of second matrix. This is a condition. Okay, let's say now let's say you have like this matrix. You have 1 by this is 1, 2 is there. This is what is 2 by 1. So then you have, let's say here 1, 2, 3, 4. This is 2 by 2 matrix. Can we multiply these two?
No, sir.
Why? Because here 1 element is there, here 2 elements are there.
Yes, sir.
1 element, how do you multiply? That's not possible. So therefore, essential condition for the multiplication to exist is number of columns of first matrix equal to number of rows of second matrix. That is a condition. Then you can multiply. So here very important here, very important, two very important things we'll discuss. So two multiplications I discussed, 2 things. See, then what is the resultant matrix? This is the AB matrix you will get, right? Matrix AB you get. AB matrix, what is the order of this AB matrix? M by P matrix you get. M by P matrix, what is that? This, and this one, what you got here? You got, no, previously you got, see, 1 force plus 2 into 5, right? So 14 you got. Here, see, here these two will go. Then what you get is 2 by 1. 2 by 1 matrix you get here.
Yes, sir.
So therefore, important, very important 2 examples I will give you. Many people get confused. So here, yeah, let's take 2 examples I will give you. Okay, directly. Okay. So okay, first general example we'll discuss. General example we'll discuss. So let's say 1, 2, 3, 4, 5, 6, and we multiply this with 1, 2, 3, minus 1, minus 2, 5, like this. Okay. Now can we multiply this or not? Can we multiply this or not?
So we can multiply this.
Yes, we can multiply. Why? Because this is 2 by 3 and this is 3 by 2.
3 by 2.
So number of columns, 3 columns, this is what is 3 rows. Number of 3 columns equal to 3 rows. So number of columns of first matrix equal to number of rows of second matrix. So resultant matrix you get is, what is the number? Resultant matrix?
2 by 2.
2 by 2 you get. See, the first row, entire row you have to multiply with entire column. So first row, first column element you get here. So I am writing directly 1 into 1, 1, plus 1 into 1.
So 1 into 1 plus.
Plus 1 into 1 plus 2 into 3.
2 into 3, 6.
Plus 3 into
minus 6.
Minus 6. Like this. Yes?
Yes.
Yeah, like that. So first row, first column you got. Then next to this entire row with second column. Now second column, what do you get? 1 into 2 minus 2 plus 15. The next second row, you have to come to second row. Second row, you are multiplying with first column. Second row, first column. 4 ones, 4 plus 15 minus 12. And then this is 8 minus 5 plus 30. Okay. All right. Second row you are multiplying with second column. All right.
Yes, sir.
Okay.
Sir, can you explain how we got the A12 and A22 elements again?
First row you have to multiply with first
The
column.
first element and the third element I understood, but
First
the-
row, yeah, first row, first column, first row, second column. This is first row, second.
okay, yes, sir. Now I
1
understand.
into 1 into 2, then 2 into minus 1 plus 3 into 5.
Yes, sir.
Next 4 into 1 plus 5 into 3 plus 6 into minus 2. Second row, first column, second row, second column. So like that. First row, first column, first row, first column, first row, second column, first row. If third column is there, third column, first row, fourth column, like that. You understand?
Yes, sir.
So that is the reason 2 by 2, na?
Yes, sir.
So like that, then this you get, what you are going to get is this is 1 and
1.
15, and then this is 3 plus 4, 7, and this is going to be 3 plus 30, 33.
32.
Okay, 2 by 2. Like that. So whenever you multiply, better you write this matrix order. So that first thing you should check this one. These both are equal or not, you have to check.
Yes, sir.
Okay, and then next, so now I'm going to give you important example. That's example. See, I'm going to give you example like this: 1, 3, 5, and then this is 4, 4, 2, 1. Now this 2 can you multiply? This is what is the order of the first matrix? What is the order of first matrix?
1 by 3.
Good. 1 by 3. What is the first you should, for multiplying, first you should write this. For second matrix, what is the order?
3 by 1.
3 by 1. Can we multiply this?
Yes, sir.
So what do you get here if you multiply?
The order of the matrix is 1 by 1.
Very good. First you should have this clarity. Many people make mistake after learning matrices, matrix multiplication. Many times they do lot of problems, but they still do mistake in this. Okay, what is that you get?
So we first row, first column.
First
So,
row you
one,
multiply.
4.
First entire row you should multiply with entire column.
Yes.
1 into
4
4
plus
plus 3 into 2 plus 5 into 1.
5.
Oh yeah. First row, first column, you get first row, first column element. That's it. First row, first column.
Yes.
First row, if you multiply second column, you get first row, second column element, which doesn't exist. Yeah, this is what is 4 plus 6, 10 plus this 50. 1 by 1 matrix, that first order matrix. Many people make mistake. So example 2, this only, now AB, BA I will do now. So that is 4, 2, 1. You have to multiply with 1, 3, 5, this matrix. Okay. So can we multiply this?
Yes, sir.
What is that? Same thing.
So the order of the first matrix is 3 by 1.
Okay.
Second one is 1 by 3.
Okay.
So the order of the resultant matrix will be 3 by 3.
Good. That you should first understand. Many people make mistake, this one. Tell me.
So first row, first column. So that will
This
be
first row, first column. They separate. First row means that doesn't exist. Row has only one element. Row is there, but it has only one element. The first entire row means what? They get confused. Where is the row? This is what is row. 4 by 1. This is 4 into 1. That's it over. Entire row multiplied with entire column. First row, I multiplied with first column. Then first row, you have to multiply with entire
second column.
So that is not plus, sir.
12.
You understand, na? 4,
yes, sir. I got it now.
4 into 3. The next, they add this. They get confused. Add. You understand? Next, 4. First row, you multiply with third column. First row, third column element.
20.
4, 5 is 20. Like that. Second row, then you should come to second row.
2, 6, and 10.
Yeah. second row you multiply with first column. Second row, first column element. That is 2 into 1. 2 into 3, 6. 2 into 5, 10. Understand? Here, third row.
Yes.
You should come to third row. 1 into 1. 1 into 3. Next one, entire row with entire column. That is 5. That's it, over. See, like this. So 4, 12, 20, 2, 6, 10, 1, 3, 5. If you want, this is after your teacher taught and then they do all the problems, you check these two examples you give to your friends. Many of them make mistake if they don't learn in proper way. Many, in the 30 students.
It is a little confusing. Like the first example, I didn't have any problem. But after doing the second example, when I go back to the first example, it seems a little confusing. Like this is really confusing because
because see here, learning, you should learn in a proper manner. So thing is that entire row, if you multiply with entire column, you get first row, second row, third row, let's say. First row, second, see, like entire row, if you multiply with entire column, you get one element. First row, first column element you get. That's why I told this one is important. A11, A12, and A13. You should know first column, first row, second column, first row, third column. You should be familiar with this.
yes,
Then you have confusion. Okay, these two you concentrate, and remaining all you will be able to do on your own.
So actually, once we get to know the order of the matrix, it becomes much more easier. Then we can estimate and understand that itself.
That's true. Okay.
Can we do more examples of that?
Yes, yes. Sure.
Okay.
We'll do once. What I would like to say here is, see, yeah, this here you are going to have this one like this. See, ABC matrices will be, you have to add A plus B, A minus B, A minus C, A, B, B, A, like this. A, B, B, A. Okay. You will be able to compute the following. This also you will be able to, because it's
So can we do the third one, second bit, and the third one, sixth bit, or any of the third one bits?
This third one, third question bits, no? This one? Yeah, that's what I'm saying. I'm showing you here how it will be. This is just.
So the fourth and fifth question we did in the class, they were very easy.
Yes. Okay, all right. This time. Okay. Yeah, this one. Okay, all right. Okay, one essential thing I will discuss and then we'll close. Okay, one thing I would like to tell you one thing. Okay, so then next multiplication, now properties of multiplication. Okay, you want me to tell more example? No? One more example we'll discuss.
So one or two examples, that's it.
6 minus 2. 3, 2, 5, 7, 1, 4. This multiplication exists or not?
Sir, I don't think it exists.
First you write, no, order.
No, it exists. It exists. 2 by 3 and 3 by.
First you should check this entire row, you should multiply with entire column. That's what you should check. That's all. Only one thing. Entire
yes, sir.
Means what? 1, 2, 3. So 3 elements are there. Here 3 elements should be there. That's it. Only this much you should check. This much.
Yes, sir.
By which you understand here, how many columns are there? 3 columns are there. 3 columns are there. Here how many rows are there? 3 rows are there. 3 elements means 3 rows must be there. So, so therefore, this equal, these two are equal, so exist, and resultant matrix is of 2 by 2. We know that. Like that. Now entire row you multiply 1 into 3, so 1 into 3 plus 2 into 5, 10 plus 3 into 4, 12. Entire row.
3 into 1, no 3.
3.
So 3 plus 10 is 3.
3 into 1. No, actually here 3 is there. 3. Right? Like this. Okay. And then next what you have? 1 into 2 plus 2 into 7 plus 4, 3 is 12. So first row I multiply with second column. First row, second column. And then this first row you multiply with second row.
First column plus, yeah.
Second row, the second row, first column. Second row, first column element is here. Second row, first column element. So 5, 3 is 15.
You don't have to do it, I understood.
Yes. Then second row you multiply with second column, and the second row, second column element you get, then 2 by 2 matrix. Like that. Okay, then properties. Next, properties. Very important. This is what is very important. Properties. Properties of matrix multiplication. Properties of matrix multiplication. Okay, properties of matrix multiplication. First of all, AB is not equal to BA in general. In general means what? In general, I said.
So there can be few specimen cases where.
Yes, exactly. Yes, some specific cases when, but if at all, if A equal to B, I'm telling few examples. If A equal to B, then what will happen? AB equal to BA, है ना? Okay.
Yes, sir.
Yeah, or if A is 0 or B is 0, either A is 0 matrix or B is 0 matrix, automatically AB equal to BA equal to 0 matrix you get. 0 and
yes, sir.
0 you get. Here also AB equal to BA. Some specific cases are there, some other cases also you may get. So, in general, they are not equal. Because the way you multiply is different. It's not like addition. But
yes, sir.
But in addition of matrices, addition of matrices what will happen? A plus B
plus B is equal to B plus A.
Why? Because you corresponding elements you multiply from A to B or B to A, corresponding elements you are going to add, but you are not corresponding elements addition. Your corresponding elements we are not multiplying, we are multiplying with entire row, with entire column. If you reverse AB, if you see here, if AB exists, then BA need not exist, first of all, need not exist. Okay? Yes or no? Why? That is, yes or no? Tell me.
Sir, can you give an example for this?
Yeah, that's what I'm telling. A is, let's say we write the matrix A 2 by 2, let's write. And B, I'll write like now, we discuss the first example, that is 2 by 1. First example we discussed. Then AB exists, yes or no? AB exists and this order, AB exists and this order is AB, IJ. This is this 2. Okay, then 2 by 1? Yes or no?
Yes.
But,
yes.
But BA.
Yeah, it's not possible.
BA, this no. BA means what? BA. So for BA, first matrix is of order 2 by 1. B is of order 2 by 1. A is of order 2 by 2.
2 into 2 by 2.
Oh, then this is not.
1 is not equal to 2, so not possible.
Yes, that's what is not possible. So this is what? This one is no 4, 5. Now, this is the first example we had. This 4, 5. So this 4, 5, I have to multiply with 1, 2, 3, 4. If I multiply this entire row, I have to multiply with entire column. Here we have only 4. Here we have 1, 3, 1, 3. So 4 you can't multiply like this. Here one more element supposed to be there, right?
Like, yes, sir, got it.
So this is 2 by 1. You cannot multiply with 2 by 2. So therefore here AB existed, but BA doesn't exist. So therefore this is important. If AB exists, then what you can say AB equal to BA, you can't say. What you can say is AB is not equal to BA in general. This is important. You should mention in general. You should mention in general. Generally doesn't. Generally it's not possible. But some cases. Okay, one very important. First thing, therefore, properties. First property is what? Number 1 property. Multiplication of matrices. Number 1, multiplication of matrices. This is number 1 I like. Number one, not commutative. Not commutative. And not commutative. Not commutative means what? AB is not equal to BA. If AB equal to BA in all the cases, then you can say it's commutative. But see, multiplication of matrices is not commutative, but addition is
commutative.
Commutative. So second, multiplication matrix is associative, but it is associative. You know why? Associative.
So how can it be associative if it's not
associative? Yeah, because your order is not changed. AB, you multiply, then you multiply C. Yeah, multiply A, yes, and then BC. BC. Okay, then you can try this. So let's say A is of order. I am writing it directly. A is of order 2 by 2, and then B is of order 2 by 1, and then C must be of order what? You know, A is of order, and then B is of order this order, and C must be of order what? You know, what? You know, 2 by 1, 1 by something. You understand? Because yes, sir. You get is then you are going to get these two get cancelled, and then you are going to get 2 by 1. 2 by and it is going to be 1 by something, either 1 by 1 or 1 by 2 or 1 by 3. Let's say 1 by 3. Okay, then what you are going to get? Then ABC is of order what? You know, ABC is of order what? 2 by 3. 2 by 3. Like that. So you multiply the AB, you multiply, and then C, or then you multiply A, B, C, you multiply, and then you multiply to A. That's both are, as long as, that means what? As long as order is not changed, multiplication is possible. Multiplication is possible. Yes, sir. Multiplication is possible. So associative. Then next you know identity. 3. Identity. Multiplicative identity. Multiplicative identity. So first order identity matrix is this. Second order identity is 1 0 0 1. Third order identity is 1 0 0 0 1 0 0 0 1. This is third order. Why you multiply this? If you multiply, this is like we write like this. This one we write I. Okay. This we write I2. This we write I3. I3. Identity matrix of order 3. I3. We write I2. This one we write I1. Okay. This multiplication. Why? You see, if I multiply 2, here we see 2, 1, 3, 4, let's say. Okay, this I multiply with, for this identity matrix is second order, 1, 0, 0, 1. If I multiply these two, what I am going to get? I have to get A into I is always A. That's what is identity meaning. Na? Identity means if you multiply A with what? If you multiply A with some B, what is multiplicative identity? If AB equal to A, then what you say is, then B is called identity matrix. Okay. B is called identity matrix. That's multiplication, multiplicative identity matrix. So already we discussed identity matrix. No, that's identity matrix means one multiplicative identity, but that we discussed in types of matrices. You see here 2 by 3, and 2 into 1, 2 plus 3 into 0 is 0. Yes or no? Yes, sir. 2 into 0, 0 plus 3 into 1. First row, second column. Second column. Yes. 3. Second row, first column. 1 plus 2. Second column, you see, observe. This is 0, 4. 0 plus 4. See, now you understand no? why we are getting the same thing. A wala I. So this we are going to get A. Yes or no? Yes, sir. Like that. Okay, multiplicative identity. Then next you got multiplicative identity, and then you got Inverse, multiplicative inverse. Multiplicative inverse. So this multiplicative inverse is what is I was telling you about this division. So if at all AB equal to I, then what we say then? B is called
I by.
B is called
Sorry. Identity match.
No, AB equal to I. I know AB equal to 1, let's say in general. AB equal to 1, B equal to what? 1 by A. Na? B is called inverse of A in real numbers, if we talk in real numbers. Okay, if AB equal to I, then B is called inverse of B is called inverse of A. B is called inverse of A. Understand? And not only that, this is important. See, if AB equal to I, then B is called inverse of A, and also A is called inverse of B. Here, the fact is this. See, if at all AB equal to I, okay, if at all AB equal to I, understand this 2 by 2, let's say this is I is of second order. So
yes,
it must be of order 2 by something here, and then B must be of order something into
that same something into 2.
2 by 2 resultant. So here what you get here 1 by 1, or you get here 1 by 1. Possible 1 by 1.
Yes, sir.
1 by 1. You can write here 1 by 1. You can write 1. That's 2 by 1, 1 by 2. Or here right you can write 2 by here 2 by 2 matrix with 2 by 2 matrix. Yes, this is possible, right?
Yes, sir.
Let's say it is 2 by 1, 1 by 2. So then BA what you get? BA what you get here? BA what you get? AB is 2 by 2. BA is what? 1 by 1.
1 by 1. Yes, sir.
1 by 1. You are going to get 1 by 1. So then also you say inverse. AB equal to I, then A is called inverse of B, B is called inverse of B. What I am saying is if AB exists, BA exists here.
Sir, I understood.
If AB exists, BA also exists here. AB may not be equal to A, but AB exists, BA exists. That's what I am writing this. AB exists, then BA must exist. If at all AB is I. If AB is I, then BA also exists. Okay, then BA also you get I. But anyway, so this one you understand. This only multiplicative inverse we discuss later. But what you understand is this one. If AB equal to I, then B is called inverse of A and A is called inverse of B. That's what I told you. AB equal to I. That's a multiplicative inverse. Okay, identity when we discuss, then we inverse also. Okay, then next. Distributive property. Fine. Distributive property. See, always this is one thing. Always multiplication you can distribute over addition. Multiplication you can distribute over addition. B plus C. So you can distribute to like this AB plus AC. This is distributive property.
Yes, sir.
But this is what is called, this is what is called left distributive property. Left distributive. Okay, and here you should note very carefully, very important remark. What is that? You have to distributing from left side. Okay. A, B. You cannot write BA plus CA. Understand? This is wrong.
Yes, sir.
This is
It's wrong.
Wrong. No, this is wrong. You have to, why? Because small multiplication is not committed. You cannot write like that.
Yes, sir.
Then next year second is if you want B plus C, you multiply with the A. From right side, this right distributive BA plus CA here. Now this is correct. This is what is right distributive property. Okay.
Yes, sir.
Distributive property. Right distributive property. Okay.
Yes, sir. Sir, so even if it's A plus B into C, then it'll be AC plus BC.
Correct. Yes, that's true. A plus B into C. This is AC plus BC. Right distributive property. From right side we are distributing C.
You have to, yes, sir. You can't start from the left side.
Yes, exactly. So now next is C. See, very important that in real numbers, see, in real numbers, AB is 0. That implies what? Either A is 0 or B is 0 or both are zeros. Any one is compulsory 0. Any one is.
Yes, sir.
But in matrix operations on matrices, this is real number. Operations on real numbers, multiplication is like this. But in matrix operations, multiplication A into B is 0 matrix. You know, A is 0 matrix. That,
yes, sir.
That doesn't imply, okay, that doesn't imply what? Either A,
that A is equal to 0 or B
is 0. This need not be 0 matrix. If this also need not be 0 matrix, but AB can be 0 matrix. Okay, you cannot conclude this way. Okay.
Yes, sir.
See, what is the example? Example is
so
like,
for addition, if we take 3, 4, 5 or 2, 3, then the elements on that side can be -2, -3, -5, -7.
No. Once you try and check, I'll write like this.
So I'm talking for addition, not for multiplication.
Just I am giving one example, you see. Okay. I'll give one example. Now we multiply this row into this column. And 0. This row you multiply this column. And 0. This row you multiply this column 0. Multiply this column 0. Yes or no? This is not 0 matrix.
Yes, sir.
Not 0 matrix, but this is 0 matrix. That's what I mean to say. All right. So now we have done with the matrix multiplication. So now what you should do, you can anyway, in the school, you are going to do this one anyway. So this exercise you are going to do. Okay, this exercise you are going to do. And if you have any doubts, you can ask. Here, some of the things I have to discuss, but anyway, tomorrow we can discuss. Okay.
Yes, sir.
Simply what you can do is, in the school anyway, you have to discuss this one. In the school anyway, you will do. I think in school they will make you do in the school only, no? Some problems.